Okay, now let's get back to our content. So we're gonna have two more things to do on the second hour here. The first hour I already told you that for differential equation you're gonna have separable equation and homogeneous equation. These are two first form that we learned on the first hour. The next two form that you're gonna learn is exact differential equations and also integrating factors. So keep in mind that the clip number 6, linear and binary differential equation, this is not going to be on the test, but I mean it's optional in terms of if you want to go to more beyond the exact differential equation, you can do linear and binary differential equation. But I think that because we only have 7 weeks after midterm, so we're gonna cover up to integrating factor here. Let's take a look pretty quick what is exact differential equation and integrating factors. So the full clip gonna be about 30 minutes each. So there are I think 4 or 5 examples in here for each clip. So you can take a look later if you want to. But today we're gonna take a look pretty quick one example on each clip. So when you watch it, so you have a sense what it is. Okay. So let's take a look at exact differential equation, which is question 5 here. Before that, let me tell you what is it first. So you have mxy dx plus nxy dy, okay, equal to 0. The same thing with homogeneous. You figure out what is your m, you figure out what is your n. So first of all, if you start from m and then you take derivative with respect to y, and then you start from n, you take derivative with respect to x. This notation it mean taking derivative with x and taking derivative with respect to y. So in calculus 1 you learn d by dx. This is derivative, right? In 1 dimension. But in 2 dimension, because you have x and y, 2 variables, so when you differentiate you have to tell them, or you do it with respect to x or you do it with respect to y. So we're gonna use d by dx and d by dy here. Because they are 2 variables, we're gonna change the notation from straight d to the curl d here. The curl d here, the curl d here. Does it make sense? What you do here is just you differentiate m with respect to y. Differentiate m with respect to y. What does it mean by with respect to y? It means that you treat x as a constant. So you just leave x as a constant and then you differentiate with respect to y. So the same thing, when you differentiate with respect to x, you leave y as a constant, so you don't have to touch y. Well, I'm gonna show you in a minute how to differentiate here. But if you differentiate m with respect to y and n with respect to x, if they are equal to each other, it's gonna call exact differential equation. Okay, and once it is exact differential equation, we're gonna have the way to solve the exact differential equation. Okay, so the way that we're gonna solve it, once you know that it is exact differential equation, it's gonna be guaranteed that the solution is fxy equal to c. You can find f from you know that integrate f, you're gonna get let me see one more time. So I want to use notation the same thing in the book. So integrate f, you're gonna get let me see notation first. So integrate, okay, f is integrate m. So let's use this notation. You can find f from f equal to integrate m dx, or you can find f equal to integrate n dy. Okay, you can find it from these 2 ways. So we're gonna show you how to do it in a minute, but this is how you can find f from there or from there. Okay, let's try to take a look at example first. Okay, this is like the quick theory. Quick theory. Okay, so now let's do the example. Okay, so use the test of exactness to show that the differential equation here is exact and then solve for general solution. So basically this is your m here, the one that I highlight in green. This is your n here. This is actually your m. This is actually your n. The theory said that, okay, we're gonna just do m differentiate with respect to y, and then you n differentiate with respect to x, and then we hope that they are equal to each other. So differentiate m with respect to y. It means you have to differentiate this thing, xy cosine xy plus sine xy. Differentiate with respect to y. Let's see if you can do it before you learn derivative in 2 dimensions. So when you differentiate with respect to y, it means you treat x as a constant. So this is actually constant x, constant x. So your y gonna be your variable. So basically the first term here, when you differentiate it, so you're gonna get, you need to use a product rule, right? Because you have y here, you have cosine xy here. So basically you can say, oh, Ajahn Krap, what we're gonna do first is we're gonna separate to dip y of xy cosine xy first. This is the first term, plus dip y sine xy. The first term here, we're gonna treat x as a constant, so x can go outside the derivative, okay? Because x is constant, so it's gonna be x differentiate y times cosine xy. And then on the second term, so keep this one first because there's no constant over there. Okay? So I pull out x because that x is like, you know, the constant. And then now I differentiate this one. So remember, differentiate product rule. U, V, so you get U dV plus V du. So it's gonna be U dV plus V du, which is 1. Can you follow that? Because like you have y times cosine cosine xy. So it's gonna be y and then differentiate this, and then that cos xy differentiate y, which is 1. You do it with respect to y. So the second term is differentiate sine xy. Differentiate sine, you get cosine. But because you have inner function xy, you differentiate, you get x. Too fast, man. Okay,นะครับ. This is, well, if you know how to do the chain rule, it's just cos, dip side, you get cos, but inside there you will x as a number. This is just not one number, so it's like 2y, for example, 3y, 4y. It's gonna just give you that number x because this is by the chain rule. So this one you can differentiate as well, so you're gonna get x, y. So take your time when you do this derivative because you have time to do it. So differentiate cosine, so you get negative sine. And then dip y, you get x. Then plus cosine xy. And then plus x cosine xy. Oh my god, this is a little bit tedious now. So you're gonna have x square y minus sine xy, and then plus 2x cosine xy, right? Because you can group it up. So this is differentiate m with respect to y. So now we're gonna differentiate n with respect to x, which is a little bit easier, I think. Should be. Alright, so one more page. We're gonna differentiate n with respect to x. So your n gonna be the function here, x squared cos xy plus e to the y. Okay, how do you differentiate this one? So of course you have to split it to this one and this one, right? First of all, don't be panic about the notation here. This is just the differentiate one, but it just make it curl because this is like in two dimensions, so they make it. This is called curl curl. This is like curl x. It just differentiate with respect to x, which means you treat y as a constant. So basically, this is actually 0. Because e to the y is constant, right? We differentiate with respect to x, that one is constant. Here, this is the one that you need to use the product rule. It's gonna be x squared and then differentiate the second part and then plus the second part, differentiate x squared, which is 2x. Makes sense? So v du v u times v, so you get u dv plus v du, right? And then now you differentiate x squared, differentiate cosine, you get negative sine. And then by the chain rule, you're gonna have y as well because this is like the constant inside there. And then plus 2x cosine xy. Same thing as before, right? Because they are the same thing with this form, so they are equal to each other. So dip m with respect to y equal to dip n with respect to x. So this differential equation is exact. I would suggest that when you do the take-home exam, you just do it slowly and make sure that you show the steps how to differentiate here. Because once you show that they are equal, so you can conclude it is exact. Okay, done.
So if you first you have to know where's the m and the n, right? Then m always have to differentiate with the y and the n.
Chai, yes. M always differentiate with respect to y and n always differentiate with respect to x. This is the theory for the exact equation. You cannot do m with respect to x. No, you cannot. M has to differentiate with respect to y. N have to differentiate with respect to x. Make sense? Yeah, this is like from the theory it has to be.
So, for example, if I just swap position between these two, so start with the n first, then m. So
it's gonna be different differential equation. So if you swap dy here, dx here, it's gonna be different differential equation because when you move things around, it's not going to be the same question. Right. Okay. Yeah. So we're gonna wrap up today by taking a look how to solve for exact differential equation, and then you can see more example in the clip. Okay. So here, the way we solve it. Okay. How to solve it? So you're gonna just start by, you need to find the solution is fxy equal to c. You can find c, or you can find f by integrate m dx or integrate m dy. Okay, we're gonna integrate m dx or integrate m, sorry, not m, n dy. You pick one. you pick one that you want to integrate, and then you're gonna get f. Okay, so we're gonna start by taking a look m and n, which one is easier to integrate. So it's gonna be both of them are hard, but we're gonna integrate this one. N looks easier because when we integrate this thing with respect to y, x squared gonna be constant, this thing gonna be the function. Okay, f, it's gonna be integrate. Okay, let's try to integrate x squared cosine xy, and then plus e to the y dy. So you split it to integrate x squared cosine xy dy. This question we have trigonometric function, so it looks hard. So integrate e to the y dy. Okay, and then now you're gonna just integrate e to the y dy. It's okay, you're gonna get e to the y. For integrate x squared cosine xy dy, what you do here is you pull out x squared first, because this is constant, right? Because when you integrate or dip with respect to y, x is constant. So integrate cosine xy dy. Does it make sense? And then now what is integrate cosine xy dy? So it's gonna be integrate cos, you get sine, right? But you have the constant over there. So can I say it's gonna be this over x? Is that okay? Or like way too fast for you? So integrate cosine. When you integrate cosine 2y dy, think what you do. So you use substitution. So it's gonna be 1 over 2 sine 2y plus c, right? So when you integrate cosine 4y dy, what you do? So it just you use substitution. It's gonna be 1 over 4 cosine sine, sorry, not cosine, sine 4y plus c, right? And then if you change this number, any number, to x, this should be x number here. And then once you integrate, you cancel 1, so you get x sine xy plus e to the y. Okay, so this is the thing already. Once you get this one, so you can make sure that it is the correct one. So you can differentiate f here, so it should get back to m here, which you will get it. It's gonna be okay. So the answer is this one. So the general solution is x sine xy plus e to the y equal to some constant c. Because it is claimed already that the solution is fxy equal to c. So it is actually, when you watch a clip, you're gonna see me trying to say that plus some constant, some constant. So the correct way is you plus constant first, and then you trying to make sure that you differentiate this one, and then you get back to m or not. Because if sometime if you don't get the same thing back, so they're gonna be more term here. But now it's just like super clean here, because when you differentiate this thing back, you get the function you want. So it's a little bit complicated concept, but take your time, because since today until Songkran, you have 1 month to watch all the clip and see more example here. And even when it's come to take home exam, you can take a look at the clip and trying to do step by step. Just watch the clip and then do the exam at the same time. It's okay as well. So I do expect that the take home exam gonna have 4 to 5 questions. I think 4 questions would be perfect because
Yes,
it's
not too much.
like one clip per one question. It's just 1, 2, 3, 4, and then that's 1, 1, 1, 1. It's gonna be okay. And then yeah, this is your free 10 point for the second half of the class. You know, we'll wait until next week so you see the score, and then I'm not sure it's gonna be high, but if the distribution is high anyway, so we're gonna get cut A at 85 as we did last semester, but the F part gonna be 30 or 35, so everyone gonna pass anyway, so do not withdraw. That is the point. But yeah, for A it depends on the committee again, but last semester we did at 85, so if you want to be sure that you get A for sure, maintain yourself at 85% and up นะครับ
If I got 84.9999
โอ้ยถามอะไรแปลกๆ okay, let's stop today because I think that your brain just not stop, it's like exhausted from differential equation already. So make sure everyone watch a clip now. 15 minutes, 30 minutes, 30 minutes, 30 minutes. It's take you 2 hours to watch the whole thing, but it's just not that easy to follow step by step, so it take time to watch this one. So we are not going to go back and talk about differential equation anymore. So next week we're gonna start talking about limit diff, vector limit diff in 2 dimensions. Okay. All right. Should be good for today, everyone. So, all right, I will see you next Monday for new content นะครับ